I don't know. Looks like 51 and 52. Fudgesicle. There's up to J. Please make sure that you can still multiply. I don't want to go over it for too long if I can avoid it. We took a little longer than I was expecting with exponents and radicals. I'm still not worried, but I may be sacrificing the odd Fridays. We are good to to J. Everybody can multiply, right? Yep. Everyone good to J, yeah? I mean, you should be, right? Like, even if you can't do it in your head like I can, I'm not showing any steps. You should be able to, distribute, right? Okay. And there's KLMN, yeah? So it's our exponent laws, and it's just distribution. Just to remind you, if I ever gave you something this barfy, if I ever gave you something this putrid, this disgusting, this Walking Dead zombie-like thing, you could still do it, right? Because you would do 3 runs of the x, then you would do 3 runs of the 2x, then you would do 3 runs of the 7, and then add up all the like terms. We could all do it, yes? Yeah? All right. So I'm going to trust that you're not lying to me, because if you're lying, you're dying. Then we're going to move on to factoring. Again, the first day of factoring, today, you already have in your brain how to do all of it, but you will need to be reminded of how to do it. Tomorrow or the next day, we will be getting into a new something that you have not seen before. But again, At the very least, you can learn a way to do it, even if you don't see why it works. All right? So we remember the following. I do not wish to write in red. We remember that factoring is the reverse of expansion. Now, if I'm going to reverse expansion, I must have to do some division. Right? At some time or another, I need to do division if I'm going to reverse expansion, because expansion is all multiply, right? Okay. There are 3 types, but of those 3 types, one of them has 3 branches that come off of it. All right? Again, you will all remember how to do it if you don't already. It's in your head somewhere. The greatest common factor is the first and easiest one because you can just look at it and see it. Greatest common factor is always to be done anytime you can. If you see a spot you can do the Gcf factoring, you need to do it at any given time. Doesn't matter when in the question, do it. Okay? And it's always the same thing. It is a 3-step process. 1, decide on the Gcf. Remember, that means you have to look at coefficients and variables. 2, you must divide all terms by the Gcf. And 3, answer in the following form. Gcf bracket quotient 1 plus or minus quotient 2 up to quotient n. If that makes no sense to you, don't worry, it will in a second. I just want to get my highlighty circle back. So, right here, you look at it, you see right away that they share a factor. What is it? 3. So I've already decided on my factor. It is my Gcf equals 3. Then, divide all the terms by the Gcf. Then, write the answer in the following form. Gcf 3, bracket, quotient 1, 6 divided by 3, 2x, plus quotient 2, 3 divided by 3, 1, done. All of you remember how to do that. You should be able to do that in your sleep. If you can't, obviously I am not mocking you or causing you any pain or undue stress, because, of course, the only reason you can't do that or remember that is because you haven't practiced it. But it shouldn't be too big an issue to get back to it. Let us look at B. It is another easy one. What is the Gcf? 2x, because I must look at variables as well. I then divide both by the Gcf, and I write the answer, 2x. 4 divided by 2 is 2. X divided by x is x. 6 divided by 2 is 3. X divided by x cancels. Done. Right? Right. Now, there are, when I leave that much white space, why is that white space there? For wrinkles, things that don't quite fit. So, let us do the first one. If I were to go 12ab squared minus 18ab plus 27ab squared cd. What would be my answer? Or, sorry, what would be my Gcf? 3ab. Then what would I do with that 3ab? I would divide everything. then I have my answer. I'm a little bit out of room. I'm a little frustrated that I didn't space that better. 3ab. What is the first answer? 4c squared minus 6 plus 9bcd. Do I care about order? Do I care about order? No. I'm happy with that, all right? That's the first wrinkle. Sometimes you'll have a variable that doesn't fit at all. In this case, we had 2. You got to leave them there. They don't just disappear. Next one, this problem is this one. This is going to be tricky. It's tricky because of the stupid way we name this factoring. What do we call this factoring? Greatest common factor. But what am I going to be taking out of here? If I take a 7, and I did this on purpose, I didn't make any of the letters common because I'm making a point with the 7. If I do that, I get 7 negative 2x squared minus 3y squared minus 5xy. Is there something else common to all three of them? Yes. We don't like a negative. If you can get a negative out, it is no longer the greatest common factor, is it? Because negative 7 is not a greater number, it is a lesser number. So, even though we call it GCF, if we can get out a negative, we want it out of there. Does everyone understand? Everybody cool? I don't need to spend a lot of time with GCF, do I? No? Okay. Let's move on to the easiest of the slightly more complicated ones. Who remembers what to do here? I know somebody does. Satjo. Multiply to 7 and add to negative 8. Right? Do we all remember this? Why? Well, x plus 2, x plus 3. If I multiply this out, I get x times x, which gets me x squared, yes? Then I get 3 times x, and I get 2 times x. Since they are both positive, I get 5x. 2 plus 3 makes 5. Then I get 2 times 3, which is 6. The middle term, which is called the linear term, or often gets the letter B, and that guy is the constant term and often gets the letter C. So in this case of x plus a, no, I don't want to use a, x plus m, x plus n, the answer is always x squared plus m plus n x plus m times n. Always. So I come back to here and I do this math, and the factors of 7, it's a super easy one because 7 only has 2 factors. What are they? 1 and 7. 1 plus 7 is 8, but I need it to be negative, so it must be negative 1 and negative 7. X minus 1, x minus 7. Everyone remembers this, yes? So what would happen if I gave you this? X plus x squared plus 8x minus 33. What would I need to do with that? Multiply to negative 33, add to 8. Priya tells me it's negative 3 plus 11 because 11 minus 3 is 8. So it is x minus 3, x plus 11. Right? Now, just to make sure, is this all right? Don't write this down, what I'm writing in blue. Is that all right? Yes or no? Yes. Is that all right, what I've written in blue now? No. If you FOIL that out, you will not get this. You will get negative 8. Everybody remembers? All right. So I'm going to give you one more of the easy ones. And remember, if you don't find this easy, I'm not calling them easy to hurt your feelings or make you feel dumb. I mean easy in the least complex of the versions of the work we are going to do. M squared minus, let's go with plus 12mn minus 45. Actually, I'm going to change that to minus 12mn plus 27n squared. How will you do that green one? Multiply to 27 and add to what kind of 12? Is it 1 and 27? Is it 3 and 9? Yes. How will 3 and 9 multiply to positive but add to a negative? Negative 3, negative 9. What is missing? I need the n. So I get back my n squared at the end. Is everybody good? All right, slide across the page. What's weird here? I don't like that 3, so I want to get rid of it. And it just so happens that 3 is also what? A GCF. So out will come 3. 3x squared plus what? 6x minus what? 8, right? Now, factor that if I can. I need to multiply to what? Negative 8. Add to what? What is it? Is it 1 and 8? Is it 4 and 2? You think it's 4 and 2, but is it? No, because one of those would have to be negative to make 8, wouldn't it? And negative 4 plus 2 is not 6. Okay, Mr. Myers, you're not fooling me. It's 4 and negative 2. 4 minus 2 is not 6. So is this done? Yes. But here's what I want you to do. I want you to put the right number here for this to work. And then I want you to change the original. So you are taking out that 18 because we know 18 didn't work and put in what would. Go. Okay. What does this have to be? There's two options. It could be 7x. Why? Negative 1 plus 8 equals 7. If it was 7x, what would be here? 21x. Okay, give me another answer. What else could it be? It could be 2, I heard someone say. Positive or negative? Positive, which would make this what? Positive 6x. What else could it be? Yes, it could also be negative 7x, which would give me negative 21x. Or it could be negative 2x, which would give me negative 6x. Does everybody understand? You all see how we can manipulate these? All right, that's the first layer of the kind of weirdo ones. Turn the page over. Difference of squares. What does an S on the end of a word in English mean? Multiple, more than one. So I must need more than one square. And what is the maximum amount of terms I can have if I want a difference? 2. So a difference of squares must be 1 squared. And then what math? Minus a second squared. So what that really is x squared minus 0xy minus y squared, which would mean I would need to multiply to y squared and add to 0. The only thing that will multiply to y squared and get me 0 is the square root of y positive and the square root of y negative. Plus, minus, 0. Y times y would get me my y squared, yes? So that, of course, is what you do here. You take the square root of x squared, whatever it is, you add the square root of y squared, and then you multiply by, what's the proper word for what I just did? Sorry, that's supposed to be a minus. Not reciprocal, conjugate. Everybody good? See how I showed you that thing in radicals? Now I'm bringing it to help you here. It builds on itself. Now, again, this one looks easy. Everyone's like, oh, okay. So, x squared minus 9, what is it? The square root of x squared, which is what? X plus, no, square root of 9, which is 3, and then the conjugate, x minus 3. All right? What if it's this? 64 minus y squared. What's that one? Root 64, which is 8. I usually do my pluses first. Root y squared, which is y, and then what? The conjugate. Yeah? Okay. 36m squared minus 9n squared. So what is that? 6m And then, okay. Let's go with 72 m cubed minus 128 m Look closely. Listen to everything I've said today, especially when I said this. Eight, okay. By 8 what? M. To get 8m, 9m squared minus what? 16. Then what? Three m. And then conjugate. Nicely done. What about this one? No, I lie. Henry. Pardon me? Yes, absolutely. That is, same thing, x to the fourth plus 2, 4, and then x squared plus 2, x squared minus 2. Do I stop there? I cannot do one more. Why? 2 has no root. So I stop. Once again, I remind you, you must understand what is going on, not follow a bunch of steps like a bunch of trained monkeys. Because if you do that, you're going to get to here, you're going to see squared minus something, and you're going to start continuing to work. And some of you will tell me that is x plus 1, x minus 1, which will make me cry myself to sleep at night. If you want that on your conscience, go ahead. Yeah? Is everybody good? Yeah? All right. Now, are there wrinkles to all of these that I could throw in? Yes. Can I show you all those wrinkles? No. I'm going to give you some practice work that has wrinkles in it. If you can't remember how to do it, and you can't think of any way forward, do you stop at that practice question? No, you skip it and move on. But now we get to the problematic one. A general form trinomial looks as such. Now, you all know what to do if that a is a 1. You all know what to do if that a can be divided out. What do we do when the a can't be divided out? Now, there are at least 7 or 8 ways that you can be taught how to deal with this. Last year, I taught 3. Between last year and now, I have learned a 4th. There are more. I cannot be bothered to learn them because one of those 4 always works. So I don't know why I would waste brain power on the other ones. And for all of you, 4 methods should be enough. One of them should work for you. All right? So, let's write one out. Let's go with 2x squared plus, let's go with 6, and let's go with plus 7x. Can I get rid of that 2 through GCF? No, I cannot. So I'm stuck with it. Now, 3 methods. I'm going to show you the one, I'm going to remind you of the one I like first, and then I'm going to work my way down to the one I like the least. All right? All right. The first one is the way I like to do this. Can I get rid of that 2? No. If there was no 2 there, then I would need to multiply to 6 and add to 7, yes? But there is a 2 there. So that is now doubled in size, correct? So instead of multiplying to 6, logically, what should I be multiplying to? 12. So step 1 is always, this is my method. This is what I like. This is what I do still. I take the A value and I multiply it by the C value, which in this case is 2 times 6, which equals 12. That's step 1. So now, in step 2, I need 2 numbers to multiply to the number 1 answer and still add to B. That doesn't change. So, to recap, I need numbers that will multiply to 12 and add to 7. What are they? 3 and 4. Everybody's cool? Now I rewrite. I know I need an x. I know I need an x. Because I need x squared here, don't I? I know I need a 3. I know I need a 4, right? But the only reason I know it's 3 and 4 is because I multiplied by 2, correct? So in the third step, I must do my number 2 answers over A. What was A in this case? 2. Second last step. Simplify, just like Mrs. Bad Crumble would. Simplify fractions. So what do I have? X plus 3 over 2 and x plus 2, because 4 divided by 2 is 2. And the fifth step. Move denominators to the coefficient spot. To x plus 3, x plus 2. And then I'm done. Do you ever need to ask if you did it correctly? No, because you check. Is 2 times 1 2x squared? Is 2 times 2, sorry, that's supposed to be a 3. No, I was right. Is 3 times 2 6? If the ends are right, the middle is right. Is everybody good? All of you who are in my grade 10 class have seen that before. You know that's the way I like to do this. If you are comfortable with that, you can right now stop watching. You can just relax, okay? But there are other methods. Now, the question now is, do I show you these other methods with the same question? Or should I use a different set of values? Different set? All right. This is a way I learned recently. This is new to me. But it's very similar. So, actually, I'm going to keep the same values. So step 1 is the same. 2 times 6 equals 12. Step 2 is the same. I need to multiply to 12, add to 7. Step 3 is a difference. Instead of doing x and x, I do 2x and 2x, because I got a 2 there. That's what I don't like. And it becomes 2x plus 3 and 2x plus 4. Everybody cool? And here's where it goes new. 4. Remove and discard any GCFs. Does this have a GCF? Does this? What is it? 2. So 2x plus 3 has no GCFs. This loses its GCF to get x plus 2. And we actually discard it. There is my final answer. I just learned that. It's almost exactly the same thing, except instead of going x and divide, you're doing 2x and dividing. It's almost exactly the same, but some kids may like it better. All right? There's a third method that if you went to another school in Abbotsford, 99% you were taught this third method. It's called decomposition. Most kids don't get it. I don't like to do it because they don't actually know what's going on. They are learning to follow steps. Do you wish to see it? Everybody is happy with one of these or a version of this that they know how to do from somewhere else? Okay. Now there is another way to do this that requires you to make like a box. And you say what can multiply to 2 and what can multiply to 6. And then you just start trying numbers and guessing. I don't like that because at this level, it's not very helpful to guess. Now this one would be really easy because it could only be 2 and 1 and 2 and 3 or 6 and 1, right? That's it. But what would happen if this was 30 x squared and this was 12? Now I could be 2 and 15, 10 and 3, 6 and 5, 30 and 1. And 12 can be 2 and 6, 4 and 3, 12 and 1. Now you're guessing a million times, right? That's why I don't like it, but a lot of people use it. Now here's the thing. At our level, these two methods are great. It doesn't screw you up. You always know the right answer because there's only one choice, right? But later on, and don't write this down, you're going to get stuff that looks like this. And when you see things like that, these methods can be a little fuzzy. Or when you see things like this. And I want you to factor that. These things can make it a little fuzzy. Okay? master something that will work with the easy ones, and then we'll worry about how to apply it to the more difficult ones. All right? Okay, I want you today, and we are having a test tomorrow. 57, 58, and 59 are all due when? Wednesday. If you can't do one of them, do you stop? No, you skip it and move on. Tomorrow, I will while you are writing your test, I will work through all of these silently, because I don't want to be talking while you're testing, but showing all the work. All right? I'll alternate. I'll use different methods. I'll even use some of those guessy ones that I told you about, and that decomposition one that I never showed you, in case you're a kid that saw it at a different school and they're like, why isn't he showing me the way I know how to do this? Okay? I will mix it up all through here. You do the method you want. If you don't, you do the method I want. What's the only thing you have to check? The answer, if it's the same answer as me, okay? Is everybody good? All right. You're going to start working for 20 minutes now. I'm going to get the last few marks from you, and tomorrow you're going to write your test. What is something you could do right now if you didn't want to do factoring? You could be prepping for your exam tomorrow and asking me questions about things like rationalizing denominators. Everybody good? Okay. But first, I'm going to get those marks